to our chemistry show for 2021. Unfortunately, we can't all be in the Sandpit Theatre together as we often are for our science shows. So hopefully you'll enjoy watching these few clips that we put together for you. So it's British Science Week as of the 8th of March and we've put the theme for this is biodiversity. So that's what our chemistry show is about for this year. For those of you who don't know who I am Mrs. Gunton and I teach science at Sandringham School. So as I said, our theme for this year is biodiversity, and I hope you can see from this image just a very, very small representation of the number of biological organisms that we have on our Earth. So the first experiment that I'm going to do for you is called Cloud in a Bottle. And the reason that I've chosen this experiment is that actually having clouds in our sky is very important, and rainfall is very important. So without rainfall, we wouldn't have oceans, and you can see with the photograph on the top left-hand side just what a diverse environment the oceans can be. Now clearly I've chosen a photograph here with lots of very colourful fish and corals and plants in it, but the sea has such a huge variety of organisms that depend on the sea in order to survive. And then here I've chosen a photograph of the rainforest. Now it might just appear to be a bit of sort of grey mixture, and then we can see the trees in the forefront. What we're not able to see there are the large numbers of animals that are living in the rainforest, and also the plants that have adapted themselves to live in such an environment. It's incredibly dense, and it's one of the most diverse environments that we have on our planet. So we want clouds and we want rain, but unfortunately sometimes, and particularly with climate change at the moment, we have too much rain, and we can see that the damage that this can cause both to us as humans. You can see somebody needing to be rescued there in a boat. You can see that you can't drive that ambulance or that car. You can also see from this overhead view of all of the damage that's happened to people's property, but also the damage that would have happened to the organisms that usually live in these areas. Clearly the plants, etc., that are submerged under the water aren't going to be able to grow properly. And depending on how quickly the water moves, you can have trees uprooted, etc. So it is important that we keep everything in balance. So this experiment is called Cloud in a Bottle, and hopefully you'll be able to see why we call it that. So I'm going to add some alcohol into this normal fizzy drinks bottle. Now I'm going to put bung, and as you can see I've got this attached to a bicycle pump or a foot pump. So let me just position it back again, and then what I'm going to do is to pump, and we will see what happens. And as you can see, I've made a cloud of vapour in the bottle. So the second experiment that I'm going to show you today is called a fire tornado, and you should be able to see exactly as this image is put. We have a container and we're able to create this spiral flame, which is very characteristic of a fire tornado. And this is a photograph of one actually occurring in nature, and you can see the amount of damage that it can do. So fire can be, and we're brought up to think of it as being very hazardous. However, without fire, this particular plant wouldn't survive, and it is not alone. There are a large number of plants that have adapted because they happen to grow in places where bushfires or wildfires were part of the habitat. It's what happened on a regular basis before any human life was there. And so over thousands of years, these plants have adapted to be able to survive wildfires, which would cause us great damage. And hopefully you can see in this photograph how damaged the rest of the plants appear to be, and yet this protea is able to flower and will grow from these parts that appear to have been damaged by the fire. There are also some types of seed. So in Australia there are seeds that cannot germinate, so can't turn into a plant without the fire to burn away their casings. And there are different trees that are designed to be in fires. So fire isn't always destructive, and it's another example of how diverse our ecology is. Now clearly this is quite an emotional photo, and you might have seen it at the start of last year when Australia was suffering some really bad bushfires, and you can see in the background of this that a lot of the habitat has been damaged, and this koala has very little living habitat for it to survive in. So we do need to be aware of the damage that fire can cause. It can be very destructive, and it can harm biodiversity. So again, it's all about balance. So what I'm hoping to demonstrate with this is one of those freak weather occurrences. Now, if you've been looking into things like the greenhouse effect and climate change, then you'll realise that one of the things that's going to change is the fact that we have more extreme weather. So what I'm doing here is, in this china bowl, which we call an evaporating bowl, I've got some tiny glass fibres. So it looks a little bit like shiny cotton wool. And hopefully it's going to allow the fuel that I've put in to spread out a bit further. Now I'm going to ignite that fuel. And you should be able to see the yellowy flame burning there. So now what I'm going to try and demonstrate is the effect that a wind can have. So I'm going to spin this, and we're going to see what happens to the shape of the flame. Now hopefully see that we start to make a spiral of the flame, and actually these do occur in nature, and they're called fire tornadoes. direction of the wind is very important in being able to control them or put them out. So the Whoosh Bottle experiment I chose to demonstrate to you because it's an example of using a fuel. And we can already see how dangerous it can be to use a fuel, particularly if we have a fire. But this, I wanted to talk about the fact of where does this fuel come from. And lots of our fuels come from crude oil. And crude oil is what we call a finite resource. That means that it will run out. The other disadvantage with crude oil is that when we burn it, we're releasing large amounts of carbon dioxide into our atmosphere. And that leads to something called the greenhouse effect, and it's now accepted by the scientific group that also leads on to something called climate change. And you'll be aware that the world is working very hard to try and reduce the amount of carbon dioxide that we release. Because clearly, if we change our habitats too much, we change the climate that we live in, then it's going to be very difficult for this biodiverse population to continue. So this is an oil platform at sea where we can drill down, and this is an old-fashioned drill that they used to use on land. And they also can cause damage to the environment and to the habitat when we have them, particularly the damage that might happen if there's any oil leaking into the sea. We've already seen how diverse that population is. And these in themselves are particularly attractive to have on the land, and you can see that there is very little living around this. Okay, so this experiment is known as the Whoosh Bottle, and I think that will probably become clear to you why we've called that. So this is one of these plastic bottles that you can put to get filtered water, and I've just poured into there a clear colourless liquid, but it isn't water. And what I'm going to do is just to swirl this liquid around. Now this liquid has quite a low boiling point, and so what happens is that this liquid is able to turn into a vapour. So that means it goes from being a liquid to a gas, and then I'm just going to leave that a little while to fill up. So I've spoken previously about how oxygen is needed for a fire to burn. And if you've been making a log fire yourself, then you'll know that sometimes to get it to start off, people gently blow, and that's because giving extra oxygen can help something to ignite and to continue to burn. So at the moment, there is air in here, so there's some oxygen in here. But what we're going to do is hope that the whole of this Whoosh bottle will start to fill up with some vapour from our alcohol that we've put in there. So an alcohol is a good fuel because it releases lots of energy when we burn it. And we're used to seeing that energy as light, so the flames that we see, and also that it will give off lots of heat energy. And that's why we often use the fuel, because we want to change the energy that's in the fuel into another purpose. So hopefully now that's been enough time for the vapour to build up. So what I'm going to do is to ignite the vapour. So I'm going to do this at a distance, and hopefully it will ignite. So I wanted to demonstrate the chip pan fire to you for a couple of reasons. One, so that hopefully you never have a fire in your house, certainly a fire caused by you cooking something. But if you did, so that you've got the safety, so that you know how to control it and to put it out. But also it was another opportunity for me to ask you to start thinking about the food that you eat and where does that come from, and also how do you cook it. So the chip pan fire is made with vegetable oil, and you probably have vegetable oil at home. Maybe it's sunflower oil, maybe it's olive oil. They all come from plants. And whereas it's very healthy for us to use that as oil, it does have some disadvantages when it comes to us thinking about biodiversity and encouraging as many organisms to survive and live on the earth as possible. Now, you might have heard of something called palm oil. It's good in one respect because it is from vegetables. It's grown from these palm trees that you can see at the top. Not all palm trees, but there's a specific type of palm that produces some nuts that you can then get the oil from. Unfortunately, a large number of our products have palm oil in them. And particularly if you look at some of the food packets, you will see that they have palm oil in them, but also if you have a look at soaps and some of the cosmetic industry has a use of palm oil. Now, I'm not about not using palm oil. What I wanted to draw your attention to is this photograph that we've got down on the left-hand side, and you can see that we've only got this tiny bit of the natural forest left, because all of this area has been chopped down and turned into a palm tree forest. Now, that in itself wouldn't be too much of an issue, except clearly that's not as diverse as the rainforest it's replaced. And so that has to have an impact on the organisms that live in there. And those of you who follow stuff about the environment will know that I've chosen this image of an orangutan because palm oil is grown in the area where orangutans live, and it's had a huge impact on them because they need trees to live in, and they're used to living in trees that are really quite tall and they move very well between them. They can't eat the palm trees, they're not going to help them to stay alive, and also the producers of the palm oil don't want orangutans in there anyway. So this animal, which is an example of our diverse organisms that we have in the world, is losing its habitat because of choices that are being made about changing a habitat. So this experiment is known as a chip pan fire. And what we've got here is a silver container that we call a crucible, and we use those in science for heating solids and liquids. And what I've got in here at the moment, as the name might have suggested, is some normal cooking oil, so some vegetable oil that you will have at home that you can use. And I've just put the Bunsen underneath that so that we've got a heat source. So at home, you will have your frying pan, you perhaps put your frying pan on to heat, and then you add the oil, and then you begin to cook. So for example, to fry an egg, perhaps you've done that in a frying pan. And you're always advised when cooking to be careful because we've got heat source, and our skin doesn't do very well with the heat source. I'm just going to move that slightly more into the middle. So this is going to take a little while, just like it does when you're cooking at home, for us to warm up the oil and see what happens. Now this is only through the heat energy from the flame. The flame itself is not coming into contact with the oil. You can see that there's a bit of a gap. We've got the crucible in between. So the first signs that we're looking for to see if the oil has got any hotter is if we get any smoke. So you might just now be able to see some smoke coming across, and I can see on the surface of the oil, which you might not be able to see, some tiny bubbles. So the oil is getting warmer and warmer, and we're getting more and more smoke. So we're going to carry on heating and see what happens. Okay, even more smoke, we're going to carry on heating. Okay, and now you can see why it's called a chip pan fire. Without me putting any flame anywhere near the oil, it has caught fire. And obviously if this happened at home, it would be a little bit scary. So I'm going to show you how you can safely put out a fire. Don't just put something that doesn't burn over the top of it and leave the heat source on. You can see there that it carried on flaming. So we would need to take the heat source away and then put something which doesn't burn on top. And I'm thinking that I need to flatten my piece of metal because it was letting too much oxygen in. And there we go. Now you might be tempted to think, oh, that's good, the fire has gone out. If you bear with me a moment, I'll just go get some tongs because that's metal's getting a bit warm. And you might just think, oh, that's great. And you take it off. Now you might be lucky, as we've been in this case, and it's still just smoking, but it's also very hot, and as soon as you let some oxygen in there, it can relight. But the thing that you shouldn't do, and that sometimes we're tempted to do, I'm just going to heat that up a little bit more so that you can see that we've got back to our flame, our flaming chip pan. There we go, it's back flaming now. I hope it continues to flame, and I will show you what not to do. And so don't ever be tempted to put out an oil fire with water. I'm just going to add a tiny bit of water and we'll see what happens. And you can see how we ended up with that big whoosh of oil. So that will make the fire far more dangerous. So don't ever put water onto an oil fire. So maybe we might reach the position where we want to change the fuels that we've been using. So we don't want to use crude oil anymore, we want to replace it with an alternative. And one of the alternatives that's been discussed is something called a hydrogen fuel cell. And I'm not going to attempt to explain how that works, but I'm going to tell you a little bit about hydrogen itself. And so we've got the hydrogen balloon experiment, and you can watch what happens when we take a balloon that has hydrogen in it, as this slow motion photograph shows us. Now, the reason that we might choose hydrogen as a fuel is that it reacts with the oxygen in the air and it makes water. And water, we've already seen, is very useful. It helps sustain a huge amount of life. So maybe that would be an alternative that would be better for us. We can also use hydrogen as rocket fuel. That has been one of the main uses that it has had, and actually hydrogen fuel cells were developed in order to have space travel. So some people say, we don't need to worry about the Earth, there's thousands of planets out there in our universe, we can go and find another one to live on. So if we were to do that, then we would need to use space travel. So we saw that we could use oil as a fuel, also that we could see that an alcohol could be used as a fuel in our Whoosh bottle. So now we're going to look at perhaps a fuel that might be a bit cleaner for us to use, and inside this balloon is actually some hydrogen gas. Okay, now I need to put some ear defenders on to do this experiment. So I've chosen the collapsing can experiment because I wanted to make you aware of changes in pressure. So you will see me be able to turn, it is a Coca-Cola can, into a collapsed can like this without me having to crush it physically. And what happens is you put some water into the can, an empty can, you heat it up until it turns to steam, and what happens is the steam pushes all of the air that's in the can normally out of the top of the can. And then when you turn it upside down, so that this hole is underneath the surface of the cold water, the steam gets turned back into water. There is nothing filling the space for the can, and the air pressure outside can push onto the can, and it's that pushing onto the can that causes it to collapse. Now we are very well adapted to living in the atmospheric pressure that we have at the moment. We can all breathe very easily. I put here a couple of examples of fish that are adapted to living at the bottom of the ocean. And as you might realise, that living at the bottom of the ocean, there is a great deal of pressure. If a human were to go to the bottom of the ocean, they wouldn't be able to breathe even if they had a gas tank, because they wouldn't be able to move their muscles sufficiently to be able to inflate their lungs. This fish looks very odd because it has been taken out, it is now at normal pressure, and you can see that it's lost all sorts of shape. However, if you take it back to the bottom of the ocean where it lives, it looks like any other fish. And that's because it's become truly adapted to the environment that it has. This is another example of an adaptation, and you might be aware of this as an anglerfish, because light doesn't make it to the bottom of the ocean, it's too far away. And so actually, most of the animals that live at that depth don't have any light. And the anglerfish works really well by light having a part of its body which can produce light. And in an environment where it's very dark, that light attracts attention. And you can see how well it's positioned away from its mouth, so that as an organism that's interested in an animal, that's interested in what that light might do, then this anglerfish can catch up other fish and have some food. And you can imagine from the name of an anglerfish, it's because this looks a little bit like a fishing rod with the sort of bait at the end of it, which is a light. So this is another example of an area of the earth where we've got very different organisms. It's a really diverse planet. We have so many different types of animal. So, if we're leaving the Earth because we've destroyed it, it's no longer able to sustain the life that we need, maybe we'll go to one of the closer planets. So, for example, you might be able to recognise this because of its characteristic red spot. This is Jupiter. So if we were just to think about, could we live in the atmosphere of Jupiter? The answer is, in some places, yes, but the pressure on Jupiter is greater than the pressure on Earth, before we even get to talk about the gravity. And so consequently, we would end up really struggling to breathe, and so this would not be a place for us to live on, even if we were able to cope with the greater gravity and with all of the other changes that we would need to make. So pressure is very important, and our adaptations to it on the Earth. So with this experiment, I'm going to demonstrate pressure and the impact of changing pressure. So I put on these special gloves, which will make me not able to do things with quite the same skill as normal. So what I'm going to do is turn the Bunsen from a yellow safety flame into quite a strong heating flame. And I've got a can that has contained Coca-Cola, as you can see. Other fizzy drinks are available. It will work with any can that's had. But I would strongly advise you not to do this at home, and you will see why if you think about the safety precautions that I'm taking. I've got the things that are holding the can called tongs. They're like sort of long scissors, but they don't have blades on the end. Now you might be able to see that actually I have some water in the can, and by being heated, that's turned the water into steam, and you might be able to see the steam coming out of the top. I'm just going to make sure that the whole of the can has got nicely warmed and it's all got lots of steam all the way around it. So I'm just going to move it around and make sure that we've definitely heated up all of this water. Now what I'm going to do is very quickly, I'm going to turn it upside down so that the opening of the can is underneath in this bowl of water, and this water has cold water in it. I might just change the position. I've got it on the can just so that I can make sure that I can definitely get it turned upside down. Let's just heat it up, make sure it's as hot as it can be. There's still be some water there, we go, got some steam coming out of it, and we'll see if we can get it to work. So my final experiment is the flame tests, and on there I mention that we can identify other planets and stars and the elements that they contain by using these flame tests and these characteristic colours. So that is an image of the Milky Way, the galaxy that we live in, and we can see that there are many, many different stars. And amongst them will also be many planets. However, I would argue that what we need to do is to look after the Earth, to ensure that we have as much biodiversity as possible, so that we can continue to live in this environment to which we as an animal are well suited and have adapted to it. And what we now need to do is to make sure that we can maintain the environment so that we can continue to have such biodiversity on one planet. The experiment this year is one of our favourites. This is flame tests. And we can use these colours to identify elements when we're looking at other planets and stars in our universe. So first of all, see if we can get this one to light. There we go. So it takes a little while because I've put a fuel in there which burns with a yellowy blue flame, but hopefully you can start to see the dark red colour. And again, we'll wait for the ethanol to burn off on that one. I might get this one going as well. So you can hopefully still see the pink tinges. And we should be able to compare, this one is hopefully a bit more purpley than this one. I know this one's, the metal ion is no longer present, and we're waiting for this one. Let me set my sprint light again, and we'll carry on. Okay, we're just starting to get the orange flicks in this one. You have to look very carefully at the flame Now the one that I like, one of my favourites, is this one at the end, which is the copper, which hopefully you can start to see has a really characteristic green colour in it. And this one here is now getting a nice orange colour. That's the sodium. So if you notice, it is slightly different. This is a much more yellowy orange than this one. So you hopefully can see the nice orange colour. And then on the edge of this one, we're starting to get a bluey green as well. And we need to wait just a little bit longer for this one to come across. Oh, we've got some really good colours. So you can see now that we're getting down to it, that's a nice orangey red. And then we've got a bright red here. And just as they finish off, this is now looking at nice green. One of these should be our nice lilac, but we might need to wait until we get to the end to actually see it burn out. Okay, that's our orange, which means that we've got sodium. This is our green, which is very characteristic of copper. And you might recognise this colour if you've ever watched any of the Harry Potter films. And you'll be aware that in the Harry Potter films they use something called flue powder to travel, and they managed to create it because they didn't have such advanced computer generated imaging, by using copper compounds to make that characteristic green colour that you see when they travel through the flue system. And you can start to see that the potassium is getting the lilac edge to it. It's always very difficult to pick this out because the flame is a blue-yellow colour anyway, but the lilac therefore is quite difficult to see in comparison to the blue. So you might feel that actually you can't notice the lilac colour, but as we're getting towards the end there, it's hopefully a little bit more obvious to you. So flame colours are very important because we can use them to identify different elements, different metals. And clearly we can't travel great distances that are needed across the universe to be able to go and take actual samples. So we can use the light that travels from stars to be able to identify the elements that might be in them.